Good morning, my dear students. Here I am to take your Chemistry 1 class. Dear students, in this class we will learn about Planck's quantum theory and also some of its problems. At first, Planck's quantum theory. Now, dear students, already you have heard about Planck's quantum theory while reading Bohr's atomic model, because Bohr's atomic model was given on the basis of Planck's quantum theory. Now, Planck's quantum theory is, according to scientist Planck, light is an electromagnetic energy which radiates from a source are called quantum of energy. This quantum of energy is called photon. The energy of a photon is directly proportional to frequency of radiation. So, the Planck's theory is the energy of a photon is directly proportional to frequency of its radiation. That means energy E is proportional to frequency, that is denoted by nu, and we can write E equal h nu. Here h is a constant and it is called Planck's constant. Here E equal energy of a photon, nu equal frequency of radiation, and h equal Planck's constant. It has a fixed value, and in SI unit the constant value is 6.626 into 10 to the power minus 34 joule second. So, E equal h nu, this is known as Planck's equation. Now, dear students, in last class we had done some equation. For example, nu equal c by lambda, where nu is frequency, c is velocity of light, and lambda is wavelength. Here also we got an equation E equal h nu. Now, by mixing all these equations, we will do some problems now. All these problems are from your book exercise. In your book, there are some problems from exercise 2.14 to 2.31. From there, I will solve some problems here. At first, problem 2.18. The wave frequency of Chittagong radio station is 1200 kilohertz. Calculate its wavelength and wave number. Dear students, look here, the frequency of the radiation is given 1200 kilohertz. You have to calculate wavelength and wave number. Now, dear students, have you remembered what is wavelength and wave number? In last class, we had done this. Wavelength is the length of two wave peak, and wave number is the frequency per meter, or we can tell wave number is the number of wave per meter. Here already we learnt an equation, that is nu equal c by lambda. Here the value of nu, that is frequency, is given. C, that is velocity of light, all you know this. Here at first we will calculate the value of lambda, that is wave length. So there is given nu equal 1200 kilohertz. I have told you that when we will do math, we will convert all the unit into SI unit. So 1200 kilohertz, we will convert it into hertz by multiplying it with 1000, and it comes 1.2 into 10 to the power 6 hertz. And velocity of light, that you know, c equal 3 into 10 to the power 8 meter per second. Now, the equation nu equal c by lambda, from there we can write lambda equal c by nu. So, by putting all these values, we get lambda equal 250 meter. 250 meter, you can keep it as answer, and also you can convert the wavelength into nanometer by multiplying it with 10 to the power 9. So after multiplying it with 10 to the power 9, the answer comes 2.5 into 10 to the power 11 nanometer. And another one, that is wave number. Wave number is denoted by nu bar, and wave number equal 1 by lambda. That means nu bar equal 1 by lambda. Lambda you got to 50 meter. So wave number equal 4 into 10 to the power minus 3 meter inverse. This is our required answer. Now another problem, problem 2.23. If the frequency of a wave is 4 into 10 to the power 14 second inverse, dear students, the unit of frequency is second inverse, or it can be also called hertz. What is its wave number? Frequency is given. You have to find out the wave number. We know wave number equal 1 by lambda. So to find out the value of wave number, at first we have to find out the value of wavelength. Here frequency is given 4 into 10 to the power 14 second inverse. And you know velocity of light, that is 3 into 10 to the power 8 meter per second. So after putting these values, we get wavelength lambda equal 7.5 into 10 to the power minus 7 meter. This is wavelength, and you have to find out wave number. Wave number nu bar equal 1 by lambda, and it comes 1.33 into 10 to the power 6 meter inverse. Now problem 2.26. The range of visible light of violet to red is 380 nanometer to 780 nanometer. Find out the range of frequency of this visible light. Here the range of wavelength is given. Here you have to find out the range of frequency. That means for wavelength 380 nanometer, at first you will find out the frequency of this wavelength, and again you will find out the frequency of radiation having 780 nanometer wavelength. So here given lambda 1 equal 380 nanometer, but when you will do math, you have to convert it into meter as SI unit. So it comes 3.8 into 10 to the power minus 7 meter. And lambda 2 equal 780 nanometer, that comes 7.8 into 10 to the power minus 7 meter. Now you have to find out two frequency. At first nu 1 equal c by lambda 1, and it comes 7.89 into 10 to the power 14 hertz. And another frequency for red light, that means the wavelength is 780 nanometer, nu 2 equal c by lambda 2, and it comes 3.84 into 10 to the power 14 hertz. So the range of visible light from violet to red is 380 nanometer to 780 nanometer, and the range of frequency of this visible light is 7.89 into 10 to the power 14 hertz to 3.84 into 10 to the power 14 hertz. This is our required answer. Now problem 2.29. In sodium spectrum, what energies in joule and kilojoule per mole are associated with radiation of yellow colored line having wavelength lambda equal 590 nanometer. Here you have to find out the energy of the spectrum that has wavelength 590 nanometer. You will find out the energy in joule and also in kilojoule per mole. So there is given lambda equal 590 nanometer. You will convert it into meter, and it comes 5.9 into 10 to the power minus 7 meter. And here you need this Planck's constant because you have to find out the energy E, that means E equal H nu by using this formula. So here H equals 6.626 into 10 to the power minus 34 joule second. You know this, and you will find out the value of E equal H nu, and nu equal we know C by lambda, so we can write E equal H into C by lambda. By putting the values of H, C and lambda, we get E equal 3.369 into 10 to the power minus 19 joule. From there, you will get the energy in joule because it is the SI unit. And you have to find out the energy in kilojoule per mole. So this joule we can write 3.369 into 10 to the power minus 22 kilojoule by dividing it by 1000, and the energy you have to find out in kilojoule per mole. Now dear students, look, this is the energy of one photon, and you have to find out the energy of 1 mole photon. So 1 mole equal what? 1 mole equal 6.02 into 10 to the power 23. So the energy of 1 mole equal, it comes 202.81 kilojoule per mole. So these two are our required answer. Now problem 2.31a. The wavelength of a beam of light is 2.8 into 10 to the power minus 5 meter. Calculate its wavelength in centimeter, frequency and the energy of one of its photons. Here look, here the wavelength of the light is given 2.8 into 10 to the power minus 5 meter. You have to find out wavelength in centimeter, frequency and also the energy of one photon. Here wavelength is given 2.8 into 10 to the power minus 5 meter, and H equal you know. So wavelength is 2.8 into 10 to the power minus 5 meter. At first you have to convert it into centimeter for your first answer. So it comes 2.8 into 10 to the power minus 3 centimeter. Now second one is frequency. You know, nu equal C by lambda. By putting these values, we get nu equal 1.07 into 10 to the power 13 hertz. And the third one, that you have to find out the energy of one of its photon, that means E equal H nu, and by putting this value, we get E equal 7.099 into 10 to the power minus 21 joule. This is the energy of one photon. So all these three are the answer of this math. Now dear students, in your book there are also some more math. You will do all the math in home, but no need to submit all. You will submit as homework from your book exercise problem 2.21, 2.25a, 2.27a, 2.30 and 2.31c. Only these 5 maths you will submit to me. So dear students, today up to this. Thanks to everyone and goodbye to all.